Now this circuit shows you two resistors connected in parallel, a 6 ohm and a 2 ohm resistor in parallel, and this parallel branch is connected in series side by side with a 3 ohm resistor. So with this we can calculate the effective resistance of the circuit. I will first find out about the total resistance of this parallel branch. So that is found in this expression over here, and we just add a 3 ohm resistance to it to get the total resistance of 4.5 ohm. Next, the readings on the ammeter and the voltmeter. The ammeter shows you the reading of the whole circuit, so we probably should start with that. And the voltmeter shows you the voltage across just the 3 ohm resistor. So the strategy is to use the total resistance and the total voltage to find the total current. So we will aim for the ammeter reading first. This total current will be the same on its return path, and this total current will be the current passing through the 3 ohm resistor. So once we know the current, we know the resistance, we can then calculate out what is the voltage across just the 3 ohm resistor. So that's the strategy here. So this is the answer, and on the whole circuit, the total current equals to the total voltage, which is the EMF of 9 volts, divided by the total resistance, which is what you found to be 4.5 ohms. So we get a current of 2 ampere registered on the ammeter. This current of 2 ampere, it does get split up across the two paths, but ultimately they will combine back, and the whole 2 amperes will flow through the 3 ohm resistor back to the battery. So on the 3 ohm resistor, the voltage across it is the current of 2 amperes multiplied by the resistance of 3 ohm, and that's how you can get 6 volts as the voltmeter reading. So just now we have figured out that the voltage across this 3 ohm resistor is 6 volts. This 3 ohm resistor is connected side by side with this parallel branch. So if this 3 ohm resistor takes up 6 volts, the parallel branch must take up the remaining 3 volts so that the total voltage remains at 9 volts. This is the voltage equation for a series circuit. So that is the strategy to find our answer to part 3. Okay, so we got a balance of 3 volts across the 6 ohm resistor and also across the 2 ohm resistor, in fact. So we use this fact to help us to solve part 4. Across this parallel branch, we figured that the voltage is 3 volts. So across the 2 ohm resistor, the voltage is 3 volts. We know the voltage across the resistor and we know the resistance of this resistor. We can simply just use Ohm's law to find out the answer, and that's how we got a current of 1.5 amperes. In part B, what happens if the switch is now closed? Now, this is a short circuit scenario, and when I say short circuit scenario, I meant that all the current is now passing through switch S path, and instead of the 6 ohm and the 2 ohm resistance. When we switch on the switch here, this path offers 0 resistance, so all the current will be flowing through it instead of flowing through these two parallel paths with a resistance. So we call this a short circuit scenario. How will this affect the current? So effectively the 6 ohm and 2 ohm resistors are bypassed, so it's as if that they are no longer in the circuit because there's no current flowing through them. So the effective resistance of the whole circuit now drops because we literally remove away resistance from the whole circuit, leaving behind just a 3 ohm resistor. So with the effective resistance being smaller, the current being inversely proportional to resistance will therefore increase. For the voltmeter reading, Note that previously the 9 volts EMF, 9 volts voltage is shared between the 3 ohm resistor and also the parallel branch, because these two things are connected side by side in series with each other. So now when we turn on the switch S, effectively again we are removing these two resistance. It's as if they are not there. Therefore the whole circuit is just left with a 3 ohm resistor where the current flows through. So therefore the 3 ohm resistor will therefore now receive the full voltage of the battery, which is 9 volts. So the voltmeter reading will therefore increase.